In previous videos, we've seen that we can pull images that other people have made. But being able to build your own images is where Docker can become really powerful to you. Let's start with a basic understanding of how a container image is structured. Container images are built as a series of layers. Each layer describes a part of how the image is built. All of these layers are stacked in order and bundled together to form the final image. This layering system is called the union file system. Each layer within the image is immutable. That means they are read-only. When a container starts from this image, none of the underlying layers can be modified in any way. So how does a container allow us to make changes? When a container starts, an extra layer is added on top, a writable layer. Any changes made inside the running container, such as writing new files or editing existing ones, are tracked in this writable layer. So why is it done this way? Why use layers at all? Because layers are very efficient. If multiple images are very similar, it's likely that some of their layers are completely identical. That means those layers only need to be created once and can be reused across all those images. And because layers can be reused, they only need to be stored on disk once, not once per image. This also makes pushing and pulling images more efficient. If you want to download an image and you already have some of its layers locally, why pull those layers again? Docker only pulls the layers that you don't already have. Now to address the big question. How do we create container images? To create an image, we provide a list of instructions that describes how it should be built. For example, we might say, start with the Ubuntu base image, then install some tools or libraries, and then run this executable when the container starts. Each one of those instructions creates a new layer in the image. We put all of these instructions together into a Dockerfile. This is a simple text file that Docker reads when building an image. To demonstrate this, let's build a simple Nginx web server image that serves a single HTML web page. This is the Dockerfile we'll use. Let me break this down step by step. First, we need a base image to build from. Technically, we don't actually need one, but it's much easier just to start with one. This is the job of the from instruction. In this case, we're using the latest Alpine Linux image. Alpine is often a great choice for a base image because it's very small and secure. The base image itself is made up of multiple layers, but we'll just think of this as a single layer for now. The run instruction does exactly what it sounds like. It runs a command within the container during the build process. So first, we install a package called Nginx using APK, which is Alpine's package manager. If you're not overly familiar with Linux, think of a package manager as an app store that downloads and installs software. Nginx is a versatile package, and we're going to use it as our web server. The next run instruction creates a new user called www.data. After that, we create a directory where our web files are going to live. Nginx will look here automatically for our HTML file. And finally, we use the chown command to set the owner of the directory to the new user that we created. Next, we have the copy instruction. This copies files from a source location on our host into the container image. The source location here is a single dot. This means current working directory. This is wherever we run our build command from. That is where our HTML file needs to be sitting. The destination is the directory we created in the previous step. And finally, we have a cmd instruction. This is the entry point to our image, the command that runs when the container starts. CMD is formatted as a list. The first item is the main executable, and the remaining items are its arguments. Here we're simply starting the Nginx web server. Alright, we have our Dockerfile ready and a simple HTML file to go with it. Time for us to build this image. First, let me show you the files we're working with. We have a Dockerfile. This is the same as the example that you just saw. We also have index.html. This is a very simple web page that Nginx will display. And finally, default.conf. This is just a simple configuration file for Nginx. Don't worry if you don't understand the HTML or configuration file. We're just focusing on containers here. Now we can build our images. For this, we use the docker build command. There are two key parts to this. The first is the source directory, the dot. This tells Docker where to find the Docker file, and it also provides the base location for all of our copy instructions. The second part is the T flag, which sets a tag on the image. The format is image name, then tag. There needs to be at least one tag on the image, but we can always add more later. Once the process completes, let's run this container. This is a standard Docker run command that you're going to be quite familiar with by now. It starts the container, gives it a name, and forwards port 80 from the host to the container. If we open a web browser and navigate to localhost, we should see our HTML page being served. Just like a full operating system, containers have environment variables. These can be added to an image at build time using the Dockerfile, or injected into a container at runtime. Now, why would we use these? Well, there's a few reasons. We might want to pass configuration to an application. The application can read the environment variable and configure itself according to the information we've provided. Or we might want to store some metadata in the image, such as a build version number or the architecture it was built for. Here we have a sample Docker file. There are 3 lines that start with env. One is for app env, one is for app version, and one is for message. Each also has a value set. The CMD instruction at the bottom, as always, is the entry point. It simply prints all 3 variables to the screen using the echo command. That's all there is to setting environment variables in a Docker file. It's straightforward, but it can be very useful. Now, I have a quick challenge for you. Create a Docker file like the one we've just made and build an image from it. Run the container, confirm it works, then stop and remove the container when you're done. Before we go any further, I want to give you a brief but very important security warning. Anything we build into an image is visible to anyone who has access to that image. Think of it like putting a bunch of files into a zip archive. They can easily be extracted later. So there are 2 big rules to keep in mind. First, don't copy sensitive files into the image. Only include files that you'd be comfortable with anyone seeing. Second, don't include sensitive information directly in your Docker file. That means no usernames, no passwords, no API tokens, and nothing that's private. Let me show you why this matters. The Docker history command lets us look at the build history of an image. This exposes the instructions that came from the Docker file. If there were any sensitive values in there, they would be visible to anyone running this command against the image. It's even easier in Docker Desktop. In the Images tab, you can open any image and browse its layers directly in the user interface. This makes it very clear just how visible your build instructions really are. For a much deeper dive into container security, check out my full Docker course. You'll find the link in the description. Now let's look at how to push our image to a registry so others can pull it. There are many registries available, but Dockerhub is the most widely used, so that's what I'll demonstrate here. First, you'll need an account. Head over to hub.docker.com and click the Sign Up button in the top right. Select Personal when creating your account, unless you're going to be using this in a work environment. Fill in your details and complete the sign-up process. I'll leave that part to you. Before we can push images from Docker to Dockerhub, we need our local Docker installation to authenticate with Dockerhub. To do this, we use a personal access token, a secret string like a password that applications can use to log in on your behalf. To create one, click your account icon in the top right, then click Account Settings. In the left menu, find Personal Access Tokens. Click Generate New Token. You'll be taken to a form with a few fields. Enter a description so you know what this token is for. Set an expiration date. You don't have to, but it's recommended for security. Set the permissions to read and write, then click Generate. You'll now see the token and a ready-made login command. Now this is important. This token string is only visible right now. If you lose it, there's no way to recover it. You would need to generate a new one. Remember to treat this token like a password. Keep it secure. I'll be deleting this one that you can see here before the video goes live, so don't worry about what you see on screen. With the token copied, run the docker login command with the U flag, followed by your Dockerhub username. When prompted for a password, paste in the token. You should see a login succeeded message. Before pushing an image, we need to make sure the image name is in the correct format for Dockerhub. We can use the docker tag command for this. The required format is your username, a /, the image name, a colon, then a tag. The combination of username and image name forms the repository name. This is what Dockerhub will use when automatically creating the repository. Now it's time to push. Run docker push with the full image name. Notice that it pushes each layer individually. Sometimes when you do this, you'll see some layers being mounted from other images. If you see that, that's Docker efficiently reusing shared layers rather than uploading duplicates. Head back to Dockerhub. You should see a new repository has been created automatically when we push the image. Click into it and you'll find more details. This is a good place to add a description of your project so others know what it does. Finally, if you ever want to disconnect your local Docker from Dockerhub, say because you're using a shared machine, just run docker logout. Now you know how to build your own Docker images from scratch. In the next and final video in this series, we'll take a look at Docker Compose. This is a way to get multiple containers to work together to build an application or service. And if you want the full picture, hands-on labs, real-world examples, and a complete detailed coverage of everything from container fundamentals to advanced deployments, check out my full Docker course. The link is in the description.